Yeah, this thing is is difficult now. It's difficult, but
Because a lot of the questions were like guesswork because I knew half of.
this one. I explained on DC motor, page 6, the same part.
Okay, yeah, I'm there.
This is called the DC motor. Yeah. Then after this, you can try redo the question again. Yeah. Okay. Later you redo on your own. Yeah. DC motor is like this. This is a very simple example of DC motor, which is the actual one will not be this simple. Yeah, the actual one, they make it more efficient. You have two magnets. Yeah. North, I put it on the left. South, I put it on the right. Then you produce all this magnetic field here. Yeah. Okay. Now I put the battery here. I have a battery. Then there is a current flowing here from positive to this blue wire. And in this blue wire, there's point A. So current will flow from A to B, B to C, C to D, D to outside here, connect to the yellow wire, then go to the negative. So it flow like that. Yeah. So if you put your eyes here, how does it look like? AB will just be 1 point. Agree?
Yeah.
B is behind A. So AB will just be 1 point on the left. CD will be 1 point on the right. Then what happened? The magnetic field is from left to right here. For point AB, current is cross. Then you use the Fleming left-hand rule. Force is down here. Agree?
Yeah.
And you do the similar thing for CD. Magnetic field to the right, current is dot, then F is up. So this AB and CD here, AB is going down, CD is going up. Then this wire here, you connect to the axle. The axle is not the conductor. What will happen to the coil here, to the blue wire? What will happen? It will rotate anti-clockwise. Agree? Because the right side you push up, the left side you push down.
Yeah.
Yeah, it will rotate anti-clockwise. So then this one you connect to the axle. The axle can be, but the axle must not be a conductor of electricity. You can either make it in plastic or rubber or wood, yeah, or any other material, but cannot be conductor, must be isolator, yeah. Then it will rotate. It will rotate. Then you can use it for this thing. It's called DC motor. Then you can use it for a toy car. Yes. Your toy car use battery, right? If you buy a toy car for small kids, then is battery here. This thing is called a DC motor. But there is one problem here. What can you see what is the problem here if we design this way? Can find? Don't know.
No.
Cannot see?
No.
This wire, yeah. This thing will be rotating.
So the
And
circuit,
this bed.
so the circuit is not always closed.
No. It's rotating. So it's a wire here. Rotating, then the wire got tangled up. Imagine you have a wire, then one side you rotate. If you keep rotating 20, 30 times, the wire get tangled. Crack. So how do people deal with this? We use these two here. A ring, half a ring. Like this ring. The ring is cut off into two parts. And the name of the ring is called split ring commutator. Yeah. So this blue wire is rotating. The yellow wire, is it rotating? Yes or no?
No.
No. The yellow wire is stationary. Yeah. The yellow wire is stationary. Then you connect. So between the blue wire and the yellow wire, they must still be connected, but the yellow wire must not move with the blue. So you use a brush here, and this is the ring. The ring is rotating along with the blue wire. The brush is stationary. The brush must be a conductor or isolator.
It should be a isolator.
Conductor, you have wire here. You want the current to flow.
Oh, I thought you meant something else.
Yeah. The brush must be a good conductor. Can it be made from metal? Yes or no?
Depends on which.
Cannot. Why cannot? Because if it is metal, then it's hard.
Copper.
Copper is hard.
Oh.
Then it makes screeching sound. Then it will stop. So you must have you must have a good conductor, but not from metal. What is it? Any idea?
No.
Carbon brush, graphite.
That's not a metal.
Carbon is metal or non-metal?
No, I mean it is.
Carbon brush is a good conductor or not?
Yeah, it is a good conductor.
Why?
Because graphite has 2 free electrons. Carbon is a non-metal.
Yeah. Split ring commutator looks like this. Yeah. This is slip ring. Yeah. But this is the diagram only. It looks like this. Yeah. Yeah. So the brush. Yeah. This one commutator. Not so obvious. Okay, anyway. So it's like this, yeah? This is DC motor. And then you can answer this thing. Yeah,
Yeah.
okay.
No.
How about AC motor?
It's the same thing, right?
It's the same thing, but don't use slip ring. Don't use split ring. You use another one called slip ring. Means this is a full ring. You understand? So it's two ring. Yeah. So you have AC motor and DC motor.